Okay, so this section 8.6 talks about functions, which is really important in advanced mathematics. Okay, all about functions. That's what it's about. So what I'm going to do is just pull off this one example that I used for a long time. Okay, and just talks about Jake, who is a plumber. Jake the plumber. And I just said, well, you know, and I don't know, let's say I'm probably off on my amounts here. So $60 just to, for a house call basically. Okay. And we'll just say 50 after that. Pretty expensive. I'm not sure this is right, but okay. So go away. What we want to do then is make a little table here. I'm going to put time here and money here. That's your cost. 0, 1, 2, 3, 4. So obviously, so he comes in the door, right? He charges you how much? $60. Okay, so that's going to go right there. All right, then he goes down, works for about an hour. So now your total cost is 110, right? Good. Okay. Well, and that's going to cost more. It's going to take more time. He's going to find something else. Now it's going to be 160. Okay. Oh my gosh, it's getting worse. He's going to have to go in your backyard and dig up some pipelines or something. Who knows what? So now we're here. And then finally, it's way bad, and that's where we're at. But maybe it's fixed. Okay? So here we have a table with time and a table with cost. Okay? This is a good example of a function for a couple different reasons. Number one, functions have an input and an output. Okay, so the input is the time, because when I was saying, okay, here's the time, people were telling me, well, here's the amount. Okay, so that's the input. All right, you were telling me what the output. That's the output. So they have an input and they have an output. The input is always called the domain, and the output is always called the range. The domain and the range. And usually we think of domain as being the x and the range as being the y. All right, so that's one reason why this is a good example of a function, because it has an input and it has an output. But what a function really has is function is a relation, all right, such that for each element in the domain, there is only one element in the range. Okay, so there's a couple words here. Relation is the first one. So a relation is just a correspondence between two quantities. All right? They don't talk much about relations in here, but if you were to take a real pure, algebra class, which I hope you don't ever do, because they're nasty. But if you did, okay, then anytime we write a pair of numbers basically, that's a relation. Okay, there's a correspondence between these two numbers. All right, I mean, it could be anything. All right, that's a relation. Okay, just as long as there's some sort of a correspondence, they call that a relation. All right, but a function is a part of that. It's just that a function is separate because you have to have one number here paired up with one number here. Okay, and the reason why this is another good example of a function is because this guy, or this girl, whoever this person is, okay, the plumber, he can't charge you two values per hour. So if this guy works or whatever works for 3 hours, right, it's $210. I mean, you know that's what it is. Okay, they can't say, well, 210, or maybe it's 5, or maybe it's both. Okay, they can't do that. It's a one relationship. All right, so that's what separates a function out from other things. It's like a relation. So a function is a relation such that for each element in the domain, there's only one element in the range. So what are some functions? What do they kind of look like? So let's start out with some order pairs. Okay, so there's some sort of a relation between these numbers. I have no idea what it is. I just made them up. But here's what we know. First of all, for every element that there is here, there's one here. So 3 and 5, 7 and 11, 13 and 19, 19, 27. All right. 1 paired with 1. That's good. Then we have a domain. Well, the domain is the input, okay, or the x. So if we concentrate on the x's, here, 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 and here, that's your domain. So you just go 3, 7, 13, 19. Okay, the range is the output, or the y's. So then that would be here, 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 and here. So that would be 5, 11, 19, 27. Okay, so that's your range. All right, domain is x, range is y, input, output. 2 and 8, 4, 16, 5, 20, 6, 24. All right, so domain, input. So what's in the domain? Look at those x's. 2, 4, 5, 6. That's your domain. Okay? And the range, 8. Oops. Get out of there. 8, 16. That's a 20, sorry. And 24. Okay? So there is that's your range. All right? Input, output. That's simple. That's a function. All right? Let's try this one. 1, 3, 3, 7, 4, 11, 5, 2, and 1, 6. Okay, so let's take a look at this one. Notice right here, and right here. What's going on with the 1? It's going to the same number. It's going to, so this shows up twice, and it goes to 3 and it goes to 6. All right. So sometimes, and I've seen this done before, they'll have 1, 3, 4, 5. Okay. 1 goes to 3, 1 goes to 6, 3 goes to 7, 4 goes to 11, 5 goes to 2. All right. The problem is right here where that 1 is going to 2 numbers and they're not the same number. So that's a violation. That is not a function. No function. We can't go to 2 numbers. It has to be a 1. Every number in the domain can only go to 1 number in the range. And that's it. All right, so that is not a function. That is a relation, but it's not a function. Right. Let's try this one. So let's go with 1, 5, 2, 5, 3, 5, 4, 5, 5, 5. What do you think? 1 goes to 5, 2 goes to 5, 3 goes to 5, 4 goes to 5, 5 goes to 5. Function?
Yeah. So how's it a function? So if it's the domain and they're all two numbers going to the same domain, it's not a function, but if they're going to the same range, it makes them.
Yeah. See, the difference is that these numbers are all going to 1, even though they're all the same. All right? But as soon as they branch out and go to 2, that's where we have an issue. So if this 1 was up here, see 1 went to 3 and 6, but down here, it's okay. They all go to the same number. That's just how it works. All right? That's so this is, yes, this is a function. Okay, yes. So the domain for this, what's the domain? 1, 2, 3, 4, 5. Yep, good job. 1, 2, 3, 4, 5. And what's the range? 5. You should put 5. You don't put it down. Yeah, it's the same thing. Okay. All right. So that's what a function is. Okay, and that's why that Palmer problem works, because it has an input, has an output, and there's a certain amount of time you get a price. All right, it's not, you can't get 2 prices. It's, it just doesn't work that way. All right, but that's what a function looks like. Okay? So that means you'll be able to do the first little bit of problems there, because all I'd ask you to do is list out domain and range and determine whether it's a function or not. All right. Okay. So it's just like Josiah says, as soon as you see this 1 here twice, then that should be a key to, we got a problem there. That can't be can't be a function. But it's okay to have multiple numbers in the range. That one's okay. So that was good. You picked up on that. So a couple more things on functions. How about naming them and evaluating? Name and evaluate. So to name a function is usually something like this. They use this terminology, HFG of x. That's how you say that. All right. This variable inside here can be anything. All right. It doesn't have to be an x, but it usually is. F, G, and H are the most common names for functions. You very rarely see them in anything else. So if we have a function f of x equals 3x plus 4, what's important is that this x and this x, so that's got to be the same variable, or else it doesn't make any sense. All right, those two things got to be the same thing. G of x equals x squared minus 10. H of x equals 2x cubed minus, or 3x cubed minus 2x squared. Right, those are all functions. as long as this variable here is the same here, 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 okay? They got to be the same. So you could have, there's nothing wrong with having f of a as long as over here you have an a. All right? You can't have an a and an x, that wouldn't make sense. So you got to use the same name there. Evaluating them, it's really pretty easy. They're going to say, okay, here we got a function f of x equal to 2x minus 9, and we want to know what f of 5, f of, let me move this down a little bit, f of negative 2, f of 10. So how do we do that? Well, this is f of x right here, okay? This is 5, so it makes sense that wherever we see an x, we're just going to put a 5 right there. And that's exactly what you do. So you're just going to go 2 times 5 minus 9, 2 times negative 2 minus 9, and 2 times 10 minus 9. So that goes like this. 1, negative 13, and 11. So see that 5, negative 2, and 10, that's your domain. And then the 1, negative 13, and 11, that would be your range. All right. Input, output. That's evaluating them. Okay, you're just putting the values in, figuring it out. There's really not anything that to worry too much with that. You guys should really do fine with that. Okay. Let's do. I want to switch here. Let's do this. Okay, let me put this on projector mode so you can see it better. There we go. All right, I'm going to type this in. Y equals x squared. Well, we got a U shape. We already knew that because we've done nothings with quadratics. Okay, so the question is this a function? That's what they're going to ask you. All right, so if we take a point and put it on here, you can see that for all these x's, there's just going to be that one y. So no matter where I put this point, there's just going to be one y value going for it. So, is that a function?
Yes.
Yep, sure is. Okay, cool. Let's try another one. Y equals x plus 1, x minus 3, x minus 8. I think I better put a number out front. 0.1. Okay, and get rid of this here. Okay, so here we got like a roller coaster deal here. All right. Again, I move this point around here. Okay, and I'm asking, is there one y for each x on there? Where is there an x that has two y's? So for every one of these x's, is there just going to be one y point? Yep. No matter what x I stop at, there's just going to be one y that goes with that. So that's a function. Let's look at this one. What about this one? Yeah? Okay, I'll go to, what if I go to 2 point, let's see if I can get to 2. So pretty dang close. If I'm right at 2, I think I can get to, can I put, well, let me put 2 in there. Let me do that. Oh, it was worth a shot. Okay, so right here, look, there's 1 and -1. I'll go there. Now, what happens up here at 1? What number is it? 1. There it is. So wait a second. Down here, 1 was -1. Up here, 1 is 1. Is that a function? No, it's not. Okay. Now, there's an easy way to figure that out. Okay, on a graph, real easy. And this is what it's called. It's called the vertical line test. I want that to be a slider. Doesn't like that. Oh, I don't know why this is a Y2 here either. Must just do that. Okay, well, forget that idea. But vertical line test. Okay, so if you take a vertical line and run it through this graph, and it hits anywhere on the graph in more than one spot, then it's not a function. So if I had a meter stick, I could kind of do it. If I ran it across here and it hit in 2 spots, no good. And it can only has to happen once, okay, for it to not be a function. So this, definitely not a function. All right. Let's try this here. What about that? Definitely not a function. Absolutely, definitely not. And that one definitely not a function, just like the one we just had. Okay. Pass a vertical line test through it. Touches it more than one spot. It's not a function. Okay. So back to this guy. Vertical line test is great. If a vertical line passes through a graph, and I don't really care what wording you want to make here. I'm just going to say intersects. You can use touches or whatever you want to do. Intersects in passes through a line, intersects in more than one spot, more than one point, not a function. Not a function. Right, that's a vertical line test. So if a vertical line passes through a graph and intersects in more than one point, not a function. Right? Very easy to use on these. So all the graphs that you have done in this, well, all the graphs that we've done. Lines, all lines. Are those functions? Yep, all except for the vertical one, that's it. What about all those parabola U-shaped things we did last week? Yep, all functions. Okay, all functions. So that's pretty much it. I mean, that's chapter 8.6. It's just evaluating, looking at the domain and ranges. All right. There's kind of some interesting ideas with functions that you can think of. Like you could say, if you look at a person, say person and their phone number. Is that a function? How many phone numbers can you have? One? So that's function, huh? Yep. It's a function. Okay. All right. So what about the weight of a package and cost to mail it? This function. What about time in a smart park and cost? Smart park downtown Portland, you go in there, you park, right?
Oh,
The time you're in there versus how much it costs you. It's a function.
yeah,
Yeah? I don't think it is.
maybe.
Well, yeah,
Maybe.
up to certain times it depends, because there's
What happens?
if you go for like less than 2 hours, it's a set price. But if you're like anywhere up to there, it's a certain set price. But then after that, it goes per hour.
So you're telling me that for 20 minutes, it's going to cost me a certain price?
20 minutes would be like $10, and then
10 bucks?
120 minutes would also be $10. So.
So another 40 minutes would be 10 bucks too?
Yep.
That's how it works, huh? All those parking things, right?
Yeah.
Yep. Yep. That's how those work. So is that function? No, it's not. Okay. So there's there's different examples of things in a real life situation where you're not going to have that. Okay. Even this one, I wonder about because I'm pretty sure there's a flat rate for certain amounts of weight, and the cost doesn't make much difference. Okay. This one though, I would agree with you. I don't think anybody can have two phone numbers. Oh, maybe they could. Oh yeah. Hey, there you go. Right. Yeah. So if you had a landline in a cell, that's right. You can have two phone numbers. That's not a function, is it? Isn't that cool? So there you go. I didn't think about that. So there's lots of different things with what's function, what's not. Okay. Do you have any questions about? If you want to look on 586, do you see anything there that you're just not 100% sure you know how to do? Talks about domain and range. Talks about evaluating. Vertical line test. Those are the only ones I gave you. No, we're good? Okay. All right. Let's go to these supplements here. See if I can find them. Yeah, here they are. Okay, this is on page. I wonder if I can get this guy to work today. This is on page S35. Let's see, I want to go to this. And I know I saw it on here.
S35.
Yeah. There it is.
I noticed these books have a few typos in them. It says supplement to 9-3 instead of 8-3.
Yeah, I know.
And then the answers, if you look at 8-1, it says 8-1 in one spot, and it says 9-1 in the other.
Does it?
Yeah, like one right above the other. If you look at answers, it says 8-1. It says section 8.1, exercise set 9.1.
It's like that in your answer book too.
Oh yeah?
Yep.
Well, in the answer book, the sections already been lined up. On our last few sections, yeah, no.
That's what I was saying. You gotta go to 9 for 8. And you gotta like skip backwards, I think somewhere in 7.
Yeah.
Yeah, I got it to work.
They change like 2 parts of the book and then forget to change what section it is and make you pay $200 for the new one. Jesus.
Yeah, you're right. They do.
We do? Are you part of it?
No, I don't pay $200. I said you do. I feel for you. I've been there. course, it wasn't $200 back in the time, but it was pretty costly. At least you get 2 classes out of 1,
Yeah.
right?
And we can sell it back to them for $50.
And you can sell it back. There you
My
go.
mom actually had this book when she was doing her math class a few terms back, so.
Yeah, there you go. So it's not all that
I'm
bad.
pass it forward, if everyone, if any other people I know have to do 60 and 65, instead of having them pay $20.
Okay, so let's see. Here's what it says. I think this is right. Let's go back one. No. Okay, so first identify the following as being linear equation, a linear expression, a quadratic equation, or a quadratic expression. Then do one of the following. If it's a linear, solve it for x. Okay. If it's a linear expression, simplify it. If it's a quadratic, solve it for x. If you have a quadratic expression, simplify it and factor it if possible. Oh, okay, fun. All right, so here's our first one. 3/2 x plus 4/5 equals 3/10. Do you think that's linear or quadratic? What do you think?
Linear.
Yep, definitely linear. Okay, so then they want us to solve it. All right, so I guess we solve it. I can solve it up here. I think my thing's still going. Let me pause that. There we go. So let's see, what do we got here? What is it? 3/2 x plus 4/5 equals. I don't know why they're having us do this, but I'll just do it. Okay, so we're going to solve this. What should we do first? Do what? Get the same denominator? What would that denominator be? 10. Now you know you could do that, or you could just multiply everything by 10, right? Because then what's going to happen to those denominators when you do that? They're going to cancel out. Alright? So if we go like this, and like this, and like this. So this would be 30 over 2, which is 15, plus 40 over 5, which is 8, and this is just going to be 3. Right, so now we have 15x plus 8 equals 3, so that's a much easier equation to deal with now.
And that's 15x equals -5.
Equals -5, and then we just
X is
divide that.
-1/3.
Yep. Okay. So I don't know why they had you do that, but it's there. What about dump down B down here? Okay, so 2 parentheses 2x minus 2 parentheses squared minus 10 equals 26. Linear or quadratic? Quadratic, definitely.
And it's an equation, not an expression.
It is definitely an equation, and it's kind of a good thing that we're actually looking at this, because there was a couple of people who I noticed on the one quiz I gave where something like this was kind of messing with them. Is it x minus 2? What is it inside here?
2 parentheses 2x minus 2.
Squared
Minus 10 equals 26.
6.
20.
This one is no good. 20.
26.
26. Okay. So what should we do first?
You should get that 26 on the other side.
If you're going to solve it by a quadratic formula, you're right. You would. But this should kind of clue you a little bit as to maybe I don't want to do the quadratic formula because I'm going to have to write this out twice and FOIL it and do a lot of work. Okay? When you see parentheses and squared like this, I would probably use that square root idea. So let's get everything over on this side. Okay? Yeah, so we're going to add 10, right? Equals 36, and then what? Divide by 2, divide by 2. right? And then square root it, see? Because then you're going to get rid of this here, and this is going to be a lot more time saving than
So,
foiling that and multiplying. Okay.
so it becomes like 2x minus 2 equals plus or minus 3 square root 2, right? If do you simplify the square root in that?
Yeah, you're breaking this down, right?
Yeah.
Yeah, that's fine. But now we still got work to do here, but not a lot. So what do we do now?
Plus 2.
Plus 2, good job. So we have 2x equals 2 plus or minus the square root. Oh, 3 squares 2. That was another thing too I noticed on one of those quizzes, is that some people were forgetting the plus and minus, so don't forget that. Okay. And then we're almost done. What's next? Yeah. Divided by 2, right? And you might have noticed on some of your quizzes that one quadratic formula ones, and I was just kind of circling these answers. All right, that's as far as I was looking for you to go, and I figured, well, once you got to that, you had the right answer. What you did after that, I wasn't too concerned about. Okay, but that's done. Okay. All right. Some people broke it down, and which is fine. You know, you broke it down. That's good. But I was more interested in getting it using the quadratic formula and getting that point to where that was right, and it wasn't you could break it down at that point. Okay. I already tested you on that stuff, so I wasn't too worried about that. All right. But when you see this, it might not be a bad idea to try getting everything on this side. Okay. Although you're right, I mean, you could move everything over to the quadratic formula. Okay. It's not gonna fail you, it just might be a few more steps. Okay, how about C, quadratic or linear?
Quadratic.
Yep, definitely quadratic. What about D?
Quadratic also.
Definitely a quadratic. Now on that one, you'd have to use the formula on it, okay, because otherwise it's going to be a mess. Because you have an x on both sides, so then you would have to use the quadratic formula on that.
Or you'd have an x and a square root x, and it would just look horrible.
Yeah, that would be a real mess. Yeah, I don't even know when you deal with those, but not here. Let's see. Then this just keeps going. Okay. You thought, oh, it's just one page. No, it keeps going. So on the next page, it says let functions f and g be defined as follows. Find the missing coordinates in the following tables. Note that there may be 2 inputs for some outputs. Well, they're not functions, if that's true. Let's see. So y equals f of x. So there's my f of x. So I'm just going to put these numbers in, right? Put them inside where x is, and you get an f. So if we put negative 2 in there for the first one, what are we going to get? I'd write in here, but. So we're putting negative 2 in for x into the f. What are we going to get? How much? 16. Yeah, good. Negative 2 plus 6 is 4. 4 squared 16. Okay. 0, what are we going to get? 36. Okay, good. Now, what about going backwards? So what if 0 is in the y column, so that's our output. Now we got to find our input. So now we have 0 equal to x plus 6 squared. So it looks like that. All right. How would we figure out what x is?
It's gotta be opposite of the square, right?
Which is?
Negative 36.
No. No, you said it right. What's the inverse or the opposite of a square?
Square root.
Square root. Okay, so if you square root here and square root here, that's 0, right? X plus 6 minus 6. There it is. Okay. There it is. So you had it right. So then we do the same thing for the other one, except it says negative 2. Okay, so then we would have -2 here. Now, what's going to happen when we do this? No real solution, huh? Yeah, it's going to be imaginary. So we would say this is no real. Okay, because there's, in this table, they're not counting imaginaries. All right? And again, that came up on your quiz that you took. I think it was Wednesday. And some people went ahead and put eyes in there. I go, well, you don't have to worry about that because we covered eyes Wednesday, and I wouldn't quiz you on something we haven't covered that day. So it says there's no real. Now on your final, though, you'll say it. You'll work it out and get a complex solution. Okay, so well, we did that pretty well. G. Let's see what do we got here with the G one. Again, it's the same thing, right? We're just going to put -1 in there and get an answer. Oh, I see why they think 2 inputs. So I got you. So those are functions. They didn't screw up. Okay. Oh, this gets better. Now over here on the next page, let's see. Let functions f, g, and h be defined as follows. Use these to answer the following. F of -4. Okay, so what's f of -4? We can do that in our heads. F of -4.